Okay, here is another example, very basic simulation example that I would like to show you. Please open a file which is called sheet, and essentially it's a sheet with a hole in the in it. So the sketch is already provided in the part. If you go to the sketch, you will see that there is a essentially the sketch with all of these features is fully defined, and there is a hole here. In order to explain that SolidWorks static analysis is not only confined to a solid bodies. Some of the time it could be surfaces, and this is a very basic example of how a surface body can also be subjected to this analysis. Let's say what it has been defined is I wanted to see if this is a very thin sheet of the metal with this geometry. I want to know that how this is gonna impact to the gravity, how gravity can impact it, how the bending could be created if I define a gravity and then have a fixture on the left side of this one. So let's create a surface based on this sketch, and we do step by step. If I go with this sketches selected, if I'm going to the surface, I wanted to create a surface out of it, and you know that the field surfaces is the best case scenario. So I would select this, the sketch is defined, and essentially all of this default is okay. And if I hit OK, then I have a surface, and you see that the surface body is, you would say, 1. This is not a rigid, it's not a solid body. There is no thickness associated with that. And it could be like any surface that you have learned so far. If you define like a fillet or anything, you are welcome to do that for this part. But I'll keep it simple. Let's save it. Let's have the simulation. Hopefully you have added in and it still is there. I start a new study and I select static and I hit OK. So similar to the step that we have done there, that we have to provide is first we have to apply material. And in order to do material here, if you see that, let me see what is this warning would look like. The thickness is not defined, and that's actually is very valid. Essentially, SolidWorks would say would identify an issue that you have a surface body, but there should be some thickness to that, even though it is a surface. He should understand that what is this, and this is a thin body, meaning that a thin body by definition is the thickness of the part should be smaller to the rest of the geometry, like the length and width of that. So right click on this and you will see that there is you can go to edit definition here, or you can go to the shell manager. They are doing the same thing, just edit definition is simpler. So here I would say this is a thin body, and now I have to define some material for that. Let's put select 1.5 millimeter material, 0.5 millimeter material here, and then I hit OK. Now this body has, you see that issue has been resolved. Now it has that one, and SolidWorks does not show a thickness. It just would be taking into the account during the calculation. But still we need to apply material after applying that thickness. So step 1, defining a material. I have to go there, and this is a let's define a aluminum, or it could be steel. Let's select a stainless steel 304 to this material. Apply and close, and you see that all the red parameters has a value in it, so it's safe to select. Connection still is not required. This is a part, is not assembly. Now we have to define a fixture, and right click on it. That's a fixed geometry, and I wanted to make the left edge as a fixed part and apply a gravity to this, to the whole part. So I would select fixed geometry, and I pick this edge. No face would be required. This is not a solid body. There would be no face to do that, so that would be edge. Hit OK. And then I have to apply the external force, and I would like to examine this part as a in response to the gravity. So right click on it, and instead of applying a force, I'm going and define gravity. And if select this part, it is a part, the face that is going to apply, it would be top plane, or you can select this face. Either way, it would be toward downward, and then you can reverse the direction. Essentially, this face would select a plane that the gravity would be perpendicular to that, which is this one, and the number is correct here. So if it was in a different direction, like upward, you have to check the reverse direction or uncheck it. Okay, now gravity, fix everything, and now we can create a mesh. One of the importance and one of the benefits of I could have defined this based on a solid body, and then I apply the material and bring it to this. It would be pretty much the same result. But in SolidWorks and working with the surfaces, the benefit is you can define much larger mesh, and the computation load would be much smaller. So I can drag it all the way to fine, and when I select it here to define a mesh, I can have a very good mesh, and the time was very small compared to the rest of the instead of like a defining with respect to a solid body. And now you see that around this edge, the geometry is really adapting how to define the mesh. Okay, we have everything, and now we can create a we can run this model to understand how this reacts to the gravity, and that's pretty much accurate. We pretty much expected this. If I look at from the side view, you will see that has been bent because of the gravity, and all the stresses and everything has been shown here that we have learned. And you will see that some areas, it like a sharp corners, it has more stress, and meaning that these are more stressful points, even though that the displacement is smaller than here. And as a matter of fact, the close to end of the plate, it has less stress. So this hole in the center creates some stressful regions that we should be careful about that. And you will see that the yield strength is still, the numbers are less than that. So this part is not gonna fail because of the gravity. And one other cool features is if you go to the displacement, of course, it's going to show you that the displacement of here compared to when it was like an original is much larger, because that's the maximum deflection with respect to original state. It actually fell down. And if I select any of this, and if I right click on the stress and go to animate, is going to create an animation that how during from the zero, like a no deflection, all the way to the full deflection, how this area is going to create it. And you will see that it's only 5 frames, and the duration of the entire animation is being selected here, or the speed of the animation. If you wanted to create more, you have to stop this animation. For example, I wanted to create 15 frame to have a smoother animation, and now I can select play. So it's going to create for all the 15, and now you see that the animation is much smoother. But it's really nice to look, maybe if I look at from top view, it would be nicer that how these stress regions are developing across from the top no deflection all the way to the full deflection, and it would give us very good information about that. And if you wanted to see a particular frame, you will pause it, or maybe I have to stop it here. No, I don't think I'm going to give a very, and also you can save to like a AVI file if you want it, or provide some option to have an animation for that. So I would hit OK, and then I can go to the displacement, and same if I wanted to have animation. So hopefully this was another example of the surfaces, and we will go back for another example of the static analysis. I'm gonna